Okay. Let's kind of set this up. Okay. So, the other day I had you just write down some notes. So the first thing was it had a little bit of SOHCAHTOA and it had the reciprocals, which we've already talked about. But remember, reciprocal, you just flip it over. But if you're looking at it as, if you just put sign is just 1 over that, but essentially all that does is flip over your fraction. So these are the reciprocal identities. Okay. The next ones you wrote down were quotient ones. So this had to do with tan. So if you kind of take it even back to the snowman, if you put in those coordinates, if you put sine over cosine, you got tan. And those are the numbers on the outside. So if tan is sine over cosine, then cotangent is cosine over sine. It's kind of like the last thing we did. If you did 1 over this, it would just flip it over. Okay? So tan, and that's how we got tan on our snowman, as I'm circling around. Okay. Last thing. If you did sine squared plus cosine squared, that was equal to 1. Okay? Remember on your unit circle, your radius was 1. So, if like one of your points was, well, let's say, okay, so that was one of them on there. Yep. All right, so if you do 1/2 squared plus square root of 3 over 2 squared, you'll get 1. So 1/2 squared is 1/4. Square root of 3 over 2 squared is
3/4.
Hey, 1/4 plus 3/4 is 4/4, which is 1. Okay? So, and it doesn't matter which pair of numbers I chose off of that snowman, it really doesn't matter as long as it was a sine cosine thing. So I just kind of picked 1. Okay, so then the other one I have on here is 1 plus cotangent squared equals cosecant squared. Okay, where did that come from? Well, if you take everything up here and divide it by sine squared over sine squared is 1. Cosine squared over sine squared is cotangent. 1 over sine squared is cosecant. Okay? That's where I got these other two. We don't use these as much, but. So now how did I get this one? I divided everything up here by cosine squared. So sine squared divided by cosine squared, it will give you tan squared. Cos over cos is 1, and then 1 over cos is secant squared. Okay? Those 3 pages of notes is what we're going to be working with these next problems. And when I said it was kind of like solving a puzzle. And the thing is, with the problems I give you, you'll have the answer. You'll know what you're trying to get to. It was just simplifying. You did this in, well, you didn't. We did this in Algebra 2 with, but it was algebraic. It was with x's and x squareds. You did factoring and you simplified. Well, this is different because I'm using Trig. Okay, so even odd identities, if you have sign of a negative, you can just pull that negative out. Okay, this has to do with a little bit of graphic stuff. Cosine, you can just drop, and then tan of a negative, you can pull that out front.
Why is cos different?
Why is cos different?
Yeah.
No, that's that's something I skipped in the last section. I was doing the inverse stuff. Because cosine had to do with the first and the fourth quadrant, and they're both positive in the first and the fourth. Where sine had to do with first and the second. Oh, I did skip that, didn't I? Just know where you can pull the negative. And the cosine, you can drop the negative, and the sine, you can pull it out front. And the tan, you can pull it out front. I don't do a ton with those, but. Okay, you don't need a snowman. You don't need that. You don't need that. You don't need that. You don't need that. Okay, here's where I'm at now. And then I'm going to just do a bunch of examples. So if you want to jot these down, if you want to just read them, you want to put your phone away.
Write these down?
If you want to. I mean, if you can read through them, and this is kind of what we're going to do. And I'll show you, I'll do several examples just to show you what I'm talking about here. Like I said, well, I keep saying in Algebra 2, but in Algebra 2, you did this algebraically, and now I'm just doing Trig with this. What's so important on that phone?
My friend is talking about some dumb song he was listening to, and I just want to see what he thinks about it.
Oh, Lord. Lord. Oh my gosh. Okay, so with the verifying, what we're going to do is transform the more complicated side into the simpler side. And you'll know when you look at it kind of which one is the more complicated side. Okay, so it's kind of like you have an answer. In the end, you have an answer. It's just, can you get there? Try to change everything into sine and cosine as much as you can, because a lot of things can go back to sine and cosine. If you have a proportion in there, you can cross multiply and then kind of go from there. You can factor, you can substitute, you can FOIL. Anything you do in Algebra 1, you can, not Algebra 1, but in algebra, you can do on here. So any of those operations will work. And it's, like I said, it's kind of like solving a puzzle. It's like you have the end. It's just, can you get there? Okay. So here's my first one. Oh, I'm gonna do this. Okay, I wanna. No, I don't want to do this one. I need to get out of here. I need to get out of here. Why did it go that far ahead? Oops. Uh-oh. Yeah, it's not. Let's go do this. Please say you're gonna work today. Yesterday was fabulous. Okay. Okay, so, you got that down? Oh, wait, I don't want that up there. Okay, so what did I give you?
Cosecant x over cotan x equals secant x.
Okay, can't, this for long. Okay, so, on this one, I first would probably change everything into sine and cosine. So what is something I can substitute in for cosecant x?
1/sine.
1/sine, okay? So, I got 1/sine,
And x is,
then what can I put in for cotangent?
x represents theta.
Yeah, it won't matter if it's an x or a theta.
What's over sign?
I can do cos over sine. Okay, don't change it into 1/tan. Try to change it into cosine and sine as much as you can. Now, if you even want to change the secant over here, or you can leave it, because that's obviously my not complicated side. If you want to leave it, or if you want to change it to 1/cosine, I don't really care. What do you want to do?
I'm doing 1/cos.
Just 1/cos, okay. So when it comes to that, it's not really gonna matter. Okay. So now, how do you divide fractions?
Flip up, multiply.
Flip and do some multiplying. So I could say copy dot flip. I do copy dot, and I flip that over. What happens here?
The sign crosses out, then you're left with 1/cos, which is
Exactly.
secant x.
Which is exactly where you want it to be. So, just at the end, you'll have the same thing equal to each other. So, when you did this in Algebra 2, you did this algebraically, you did this with polynomials, you did that kind of stuff. So I'm just kind of doing the same stuff, but I'm using trig identities, okay? So, like I said, it's kind of like a puzzle. You substitute in there as much as you can, and then in the end, I should have the same thing equal to the same thing. This is what I meant by the more complicated side, you know, not that this is real complicated, but it was just a fraction equal to just something, okay? In the end, if you didn't change that and just left it secant, when you got down here to 1/cos, you could have just plugged in secant. In the end, I have the same thing equal to the same thing. Okay. So, let's, I should space that out better. And I'll just really probably today do several examples. That's what I'm thinking I'll probably do. Okay. Okay, I don't remember how to do stuff on here. Okay, what was it?
Cos, cosecant, and then tan equals 1.
Cos,
And then 1, and then cosecant, and then tan, and then equals 1.
okay?
So then you convert that to.
So this is already
Yep.
what you want, so leave it alone.
And then you have 1/sine, and then sine over cos.
Okay, when I did this with regular, if it makes you feel better to kind of put a 1 underneath there, just to know that that's up top and a 1's down below, so be it. You don't have to do that, but if it helps you, do it. Okay, so you got a cos up here, cos down here, sine here, and a sine here. Everything canceled out. Remember, it doesn't cancel out to 0, it just cancels out to a bunch of 1's. Okay? Okay, let's do that. down? I think I can just write on this. I wonder what it'll do. Oh, my page should be screwed up. Okay. So, oops.
Plus sign equals cosecant.
Okay.
So wouldn't it be the?
And then you do cos over sine, right? This is already how you want it. Do you want to change that one on the end or leave it? Oh, you,
Okay.
it won't matter. It won't matter. A lot of times kids will just change it all because it says Haas told me to change the sine and cosine, change everything, and that's fine. Okay, so when I multiply this, I'm gonna get cos squared, right? Okay. And if you need to kind of do this, do that. All right? Okay, now remember, don't be that kid that wants to cross these off. Remember, you can't cross those off. The only time you cross off stuff like that is if it's a multiplication problem. If you're multiplying, yes, cancel away like I did on that last one, but on this one, not so much. Okay, so common denominator, how do I add fractions? Common denominator, you do like 2/3 plus 1/2.
Times the 5, the greatest.
Okay, so right now, its denominator is 1. So,
Times by sin x.
okay, so all I'm gonna do is take top and bottom times sine x, because one is sine, one is a 1. Can I go ahead and just combine them? Because remember, this will give you sine squared over sine, and since they both have a common denominator, I can add the tops. Oh, I want this over here. No, I don't want you right there.
So, and because of the.
How do I get this out here? Oh, okay. Where's all the stuff then? It's all coming back to me a little bit here. Okay, so what's cosine squared plus sine?
1. Then 1 over sine is cosecant.
And then since we had changed it up there, stop here. If you didn't change it, you would just put cosecant. That's why I say it doesn't matter to me if you want to change everything, or if you kind of, well, I'm just gonna leave that and I'll get there. It's not gonna matter to me.
Yeah.
That's so long. I'm so happy. Okay, let's do this one. This quit working on. Over a year ago.
So would you go on this one?
I would not substitute anything first. What I would do first is get rid of those parentheses and then substitute. Because if you substitute right now, then you're gonna be foiling fractions in there and you probably don't wanna do that. So my advice is FOIL. Okay. So, forget that, okay. What was the second set of parentheses?
Cosecant minus cotangent
Equals,
sine.
okay. So the first thing I would do is, yeah, FOIL. So like I said, anything you didn't algebra do, you can do this here, but you're gonna end up, the trig stuff. Good there? Yep. I mean, doesn't matter the order,
Yeah. Okay.
just as long as everything's.
Mhm.
Okay, now, do what you were going to do. So you got 1 over sine. You got cos over sine. And that's just straight substitution. I really didn't do anything other than just substitute. Good there? Yeah, good? Okay, so now I want you to take a look at that.
It's the same thing. I think it's 30.0.
It's the same thing, one's positive, one's negative. So that whole middle part is eliminated. Okay, now I wanna look at the leftovers here. Do these have the same denominator?
Yes, so it would just
Okay.
be 1 over sine. 1 plus 1, 2 over sine. Wait. Oh, you multiply.
So if I multiply this, that'll give me cos squared over sine, right?
Yep.
So then I have 1 minus this right here. Okay, so far so good. Yep. Okay, so now I got 1 minus cosine squared, so I'm gonna take a little detour right here. Okay, so I know this, but up there I have 1 minus cosine squared. So what can I substitute in for 1 minus cosine squared?
You could change the,
If I move this over there, it becomes what?
1 minus x. So the sine x over
So wherever I see a 1 minus cos squared,
is a sine squared x over sine
hey.
x, which is just sine x, which equals sine x.
Okay, so
Wow.
if I substitute that in, then, oh, I can change color. I'm just gonna do this. So that will just cross out one of those, and so you're left with sine. So when it comes to this right here, it can be manipulated. You can move some stuff around. So if you have, 1 minus, well, if I put that over there, then I'm left with it. You can move stuff around. So don't think on the Pythagorean theorem ones that it has to look like that. Or if I have cosine squared plus sine squared, it's the same thing. So, but you can move some stuff around. So don't be thinking that's just is what it is. You can move some stuff. All right. That's a foil one. Oops. I don't know. Do you want to do one?
Can we do the one with,
Oh.
that's complicated on both sides? Like that?
This?
It's complicated on both sides.
this one's gonna be a heck of a lot easier than what you're thinking. And everybody's like, "Who that one? No. Yeah.
I need to start.
Why?
Because they seem so simple, but I feel like they're not as simple as I think.
Don't overthink it.
Which would mean that we're doing it wrong.
That's what I told Alexis today. She's like, "Oh." She goes, "I'm overthinking stuff." You done any of the homework?
Yeah. But it's just,
Okay, we got this. Okay, 7, what was it again?
7 sin x plus 5 cos x
Is this all over the same thing?
sin x plus cos x equals 7 secant x plus 5 cosecant x.
Like that?
Yep.
All right.
I don't think they were added together. I think
Oh, the bottom wasn't. I guess I could have just taken the sign out. So it's like that. Like that? Okay. With this, what I did was bust apart this fraction right here. Okay, so I just tore it apart, what it would look like before you added. And then what happens in this first one?
The sin x gets eliminated.
What happens in the second one?
It's just 5 cos,
Ooh.
or 5 over sin x.
So if you change those from the get-go, you would be done. If you didn't change them from the get-go and you left them, because remember, if I plug in 1 over secant right here and you did a copy dot flip, that would just put it up top. Same thing over here, if you did 1 over cosecant and copy dot and flipped it over, it would just bump it up. Wasn't as hard as it looks, but sometimes if they both look a little sometimes I get kids that work on this side a little bit, work on this side, and then one becomes not so, it's like, okay, I can get there. But, because that's just another FOIL one that you've already done. Oh, we're not doing that today.
Okay. Not
So-
bad.
It's not bad, and like I said, it's kind of like a puzzle. It's just kind of, I like doing them. I know that's weird, but it's just, it gets that brain going. Okay, so, what I want you to do is to look at,